Hello. So what we got? Okay, this one today is installing a 600 watt. That'd be pretty insane. 600 watt DC to AC inverter. I don't know if you can see it's in reverse. So what we got here is one I found on Marketplace. It's a Power Boss. Swapped it for a 4-pack, but we had it for 30 bucks. So it got down to 20, where it worked out between $2 and 600 watt continuous power, which is what you want to see. Continuous power, so that you know that it will supply that. So peak power is probably a fair bit higher. Just so happened that it's, when I looked at the writing on it, sold and serviced by Red Arc Electronics. So it's supplied by Red Arc, which is quite a predominant brand. So we jumped online and had a look at a Red Arc 600 watt inverter, and you're looking about $800. So, and this was brand new. The guy bought it, and he had all these envisions of powering his and charging his hand tools in his ute, but he's gone with a different way. And yeah, so quite portable, quite light. I haven't used this model or brand before, though, but being Red Arc, it's usually repackaged into a Power Boss, so they probably made a Red Arc one, same box and everything else like that. And yeah, so it's got 10 amp outlet, 240 volt AC. From the looks of it, it's really well built. Just even looking in the back, just the feel of it, you can tell it's been Australian manufactured, distributed by Red Arc Electronics. It might not be, I was saying it's made in Taiwan, so it's probably, they probably import a lot of their stuff too. I wouldn't know, I haven't looked into it too much, but just having the Red Arc on it usually means that, yeah, if they're going to put their name to it, they would be quite good. Now it's come with these 8 gauge leads, which, you know, that 8 gauge can, at this length, easily 100 amps. But what I'm going to do, so you got these 2 leads and the lugs, instead of lugging it straight to the battery, I want to be able to disconnect it. So I'm going to, at 600 watts equals 50 amps at 12 volts. So essentially times 12 by 50 equals 600 watt. 100 amps is 1200 watt. So just to keep it more efficient and just losing less power is, you're losing less power due to resistance in the cable. I'm going to double it, terminate it to here, which then I can actually use this lead for other things. Put that onto 2 batteries and have one Anderson plug. So I'll bring this down, and yeah, so essentially I'm just going to do what I normally do. Instead of cutting it, I'm just going to strip this insulation back about here. Yeah, like so. Probably easier to use a Stanley knife, sharper. Put one in here, bag of goodies. As you can see, we do this out on the road. So you usually always cut away from yourself. You don't want to cut towards yourself. This Stanley knife's quite sharp, so what it tends to do, bite into the copper a bit. So I'll just fold it in half, marked where I wanted to strip it, and then it can go like so. I tend to do this. A lot of people just cut the cable and strip the insulation off. I do it this way because you've got a continuous cable all the way through. You're always going to have better joint, in my opinion. And the thing is, that's the difference between electrical trade or having some sort of electrical knowledge and, you know, trying to keep maintain the integrity of the installation, the best ability. See, it's quite easy. I've actually see how sharp that Stanley knife is. Cut one of the strands, but as I said, it's continuous all the way through when I crimp it. So just bring it like that around, like so. This is a new blade, so she's pretty sharp. You can always use gloves, but it's a bit hard when you're, and I said be careful when cutting towards yourself. Even just grab the side cutters, trim that off, like so. Yeah. There we go, and what we've got here is a nice bit of bright copper. As you fold that over, now as you can see in the past, I'm showing you these with the Anderson plugs. These pins come out, and what I can do is that should slide over there and be a nice tight fit at 8 gauge. You can fit 2 gauges into there nicely, as you can see. Push her in. Being as it slides into the actual back of the plug, you can have that bit there showing a little bit. It's going to be hidden. Just make sure that you cut that off. You don't want that sticking out and then touching something, especially being positive. Wrap that around. If you get pedantic, you put a bit of heat shrink around there. Yeah, which we might do. I'll show you. Depends on, keep this video long, short. So do this, you can do all this stuff on the road. Got the pliers. Said because I've got that loop in there, like I've said before, goes up and around. It's even better because when I clamp, just using pliers, these electrical pliers, the channel lock, US made. As you can see, you'd think using a crimping tool, but that there pushes that pin punches essentially. As you can see there, pin punches into that, and you're not pulling that out in any time in a hurry, like so. That's not coming out. That's a good join. Grab your terminal, just make sure you put it in the positive. Got a little notch there on the back of the tab, so that goes into the back here, so it slides up. That little notch locks onto there, so that makes these reusable. If you can buy the pins separately, but as you see, this slides up. When you got the right size cable in there, makes it a lot easier. You'll see it slide in. There we go. See that it's nice and tight in there, so the insulation was sort of stopping it. As you can see, it's sliding up. You hear it click, and she stays in. But see how she's up in there tight, without any of the copper showing, and there you go. So that will come down. Put this on here. You got a grounding wire there, which you can earth to. That's a good idea. That's whatever earthing bonding it has, especially for the 240 volt side of things. Just helps ground that, bring earth back to the inverter. See now, look, these cables came with this, and as you can see now, I have a good solid connection, and that's taking what they already gave me. Yeah, and essentially I've made it half the resistance. Yeah, that would be good for in excess of 100 plus amps easy. But yeah, now it's in there nice and tight. Grab this, got little spade bits in there, but nice and tight. That's pretty in there, that's not going anywhere. Then I'll put the neutral wires the other way in here. Probably keep it away from restricting the fan. Turn them around, see it still turns a bit. Get them up nice and tight. They're not going anywhere. Mate, neutral wires come out a different direction. And yeah, so same thing for this one. So that will just strip back, slide into there, and then bolt that to there. Now I can just plug that onto my Anderson lead that I already installed on the battery. This one I most likely will put through what's called DC bus. These came, but won't go into that. That's just nice and easy. plug and play. Now I've got 240 volt. I've actually got one of these wired with the lugs onto my car battery, so I could walk up to that and just plug it straight into that if I just had a normal car, turn the car on, and I've got 240 volt. 600 watts at 240 is roughly about 2.2 to 2.5 amps. Easy enough to power most things that you're going to power. Got a little guitar amp here I'm going to play with, and it's only 20 watts pulls, which is nothing at 240. But you know, I've got a toothbrush hair charger that's 240. Now I can plug it in and charge it while I'm out on the road. All right, ciao.